Welcome to Global Trends. Please subscribe and hit the bell icon for more breaking updates. Hello science fans, welcome to a journey that takes us right to the center of our cosmic neighborhood. Today, let's shine a light on our sun, the true engine of our solar system. It's not just a bright spot in the sky but a dynamic, ever-changing sphere of energy and power. Right now, August 21st, 2025, the sun is the anchor holding our planetary family together with its immense gravity. Every planet, from tiny Mercury to distant Neptune, is locked in a delicate dance around this blazing star. Without it, Earth and the other planets would drift into the cold darkness of space, lost and alone in the vast emptiness. The sun's gravity is the invisible thread that keeps our solar system intact. But the sun is more than just a gravitational force. It's our main source of energy, sending light and warmth across 150 million kilometers to power life. Every ray of sunlight that reaches us is a gift, fueling everything from the smallest microbe to the tallest tree. Plants use its energy for photosynthesis, creating the food we eat and the oxygen we breathe. This process forms the foundation of every food chain on Earth, connecting all living things back to the sun. The sun's heat drives our weather, shapes our seasons, and makes liquid water and life possible. Without its warmth, our planet would be a frozen wasteland, unable to support the incredible diversity of life we see today. Every sunrise is a reminder that we owe our existence to this star. The daily rhythm of light and dark sets the pace for life on Earth, guiding everything from animal migrations to human activity. The sun's steady energy output has allowed life to flourish for billions of years. From ancient forests to bustling cities, every living thing depends on its reliable glow. When you feel its warmth, remember, you're experiencing the power of a massive nuclear furnace millions of kilometers away. Deep inside, atoms fuse together, releasing energy that travels across space to reach us. Its stability is why we're here today. The sun has burned steadily for over 4.5 billion years, providing a constant environment for life to evolve and thrive. The story of Earth is inseparable from the story of our sun. Every chapter of our planet's history, from its fiery beginnings to the present day, has been shaped by the sun's influence. It's our provider, protector, and constant companion in the cosmos. As we look up at the sky, let's remember that the sun is not just a star, it's the heartbeat of our solar system, and the reason we are here to wonder about it. So how old is the sun? About 4.6 billion years. For all that time, it's been in its most stable phase, what astronomers call the main sequence. Deep in its core, nuclear fusion smashes hydrogen atoms together to form helium, releasing immense energy. This process is what keeps the sun shining and life on Earth thriving. The sun's huge hydrogen supply means it can keep this up for another 5 billion years. Think of it as a car with a massive fuel tank. It's not running out anytime soon. This long, stable period has given life on Earth the time to evolve. Our sun is a middle-aged star, reliably turning hydrogen into helium and providing perfect conditions for our world. We're lucky to be living in the glow of its peaceful youth. But even stars have lifespans. After billions more years, the sun's core hydrogen will run out. Without fusion to balance gravity, the core will collapse and heat up, while a shell of hydrogen around it ignites in a final burst. This furious burning will push the sun's outer layers outward, causing it to swell dramatically. The sun will transform from a familiar yellow star into a red giant. Its outer layers will expand and cool, glowing a deep red. This marks the end of the sun's main sequence phase. The transformation will take millions of years, but it's the beginning of the end for our star as we know it. The sun's next act will be its most dramatic yet. As a red giant, the sun will become almost unrecognizable, hundreds of times larger than today. Its outer layers will swell outward, transforming our familiar yellow star into a vast, luminous sphere that glows with a deep, fiery red. The sun's surface will cool, but its sheer size will make it appear more brilliant and menacing than ever before. Mercury and Venus will be swallowed by its expanding atmosphere. These inner planets, once closest to the sun, will be consumed in a slow, relentless inferno, their surfaces vaporized and lost forever within the sun's growing envelope. Earth's fate is uncertain. It might be engulfed, or its orbit could drift outward as the sun loses mass. As the sun sheds its outer layers, the gravitational pull on Earth will weaken, possibly allowing our planet to escape total destruction. But even survival comes at a terrible cost. But even if Earth escapes, the intense heat will boil away our oceans and strip the atmosphere, leaving a scorched, lifeless rock. The blue planet we know will become a barren wasteland, its surface baked and its air lost to space. no life could survive this phase. Plants, animals, and even the hardiest microbes would perish in the relentless heat and radiation. The legacy of life on Earth would be erased, leaving only silent, empty landscapes behind. The red giant phase will last about 1 billion years. During this time, the sun will pulse and change, sometimes growing larger, sometimes shrinking as it burns through the last of its fuel in a dramatic cosmic finale. From a distant planet, the sun would appear as a vast, glowing red orb dominating the sky. Its light would cast an eerie crimson glow over alien landscapes, a reminder of the sun's immense power and the changes sweeping through our solar system. The habitable zone will shift outward, possibly thawing icy moons like Europa or Enceladus for a brief time. For a fleeting moment, these frozen worlds could see liquid water on their surfaces, creating a temporary oasis in the cold outer solar system. But this window of habitability will be short-lived. As the sun continues to evolve, even these distant moons will eventually freeze again or be stripped of their thin atmospheres. The sun's transformation will reshape the solar system, leaving behind only memories of the world we once knew. Orbits will shift, planets may be ejected, and the familiar order of our cosmic neighborhood will be forever changed. Eventually, the sun will shed its outer layers, ending its red giant era. These layers will drift away, forming a glowing shell of gas and dust that expands into the darkness. What comes next is one of the universe's most beautiful sights. The sun's cast-off material will create a planetary nebula, a cosmic cloud of color and light marking the end of the sun's life as a giant. The sun's farewell is just beginning, a final act that will echo across the galaxy for millennia to come. After the red giant phase, the sun will shed its outer layers in a series of cosmic pulses. These pulses are so powerful that they push vast amounts of stellar material away from the sun, creating expanding shells of gas that move outward into the darkness of space. Over thousands of years, this process will strip away nearly half of the sun's mass, leaving behind only its hot, dense core. These glowing shells of gas will drift into space, forming a planetary nebula, a stunning, colorful cloud lit by the sun's exposed core. The nebula will shine brilliantly, illuminated by ultraviolet light from the hot remnant at its center, causing the gases to glow in vibrant hues. Each nebula is unique, with shapes and colors created by different elements like hydrogen and oxygen. Some nebulae appear as perfect rings, while others take on more complex, asymmetric forms, sculpted by magnetic fields and stellar winds. The interplay of these forces creates breathtaking patterns across the cosmos. This is cosmic recycling. The sun's elements return to space, ready to form new stars and planets. The material ejected by the sun will mix with the interstellar medium, enriching it with heavier elements forged during the sun's lifetime. The planetary nebula will glow for only about 10 to 20,000 years, a brief moment in cosmic time. Compared to the sun's billions of years of life, this phase is incredibly short, yet it is one of the most visually spectacular. Eventually, the gas will fade into the interstellar medium. The once bright nebula will become invisible, its atoms scattered far and wide, blending into the vastness of the galaxy. The sun's carbon, oxygen, and other elements will become the building blocks for future worlds. These atoms may one day be part of new stars, planets, or even life itself, continuing the endless cycle of cosmic evolution. The planetary nebula is a spectacular, fleeting finale for our star, a final burst of beauty before the sun's story enters its last chapter. But at its heart, something extraordinary remains. The sun's core, now exposed and shining as a beacon in the darkness. The sun's core will begin its final transformation, becoming a white dwarf, a dense Earth-sized remnant that will slowly cool and fade over billions of years, marking the quiet end of our star's incredible journey. What's left after the nebula fades? The sun's hot, dense core, a white dwarf. It's about the size of Earth but contains half the sun's mass, making it incredibly dense. No more fusion happens here. It glows only from leftover heat, like a dying ember. Over trillions of years, the white dwarf will slowly cool and fade. Eventually it will become a cold, dark black dwarf, a theoretical fate since the universe isn't old enough for any to exist yet. The sun's journey ends as a silent, invisible remnant drifting through space. This is the final chapter for stars like ours. The elements forged in the sun will live on, scattered across the galaxy. The sun's story is one of transformation, from brilliant star to cosmic memory. Its legacy will shape the universe for eons to come. The sun's end is unimaginably far off, about 5 billion years from now. Humanity's entire history is a blink compared to the sun's future. There's no danger to us or countless generations to come. Understanding the sun's life cycle is a triumph of human curiosity and science. By studying other stars, we've pieced together this cosmic story. Our sun is just one of billions, each with its own journey. The atoms in our bodies were forged in ancient stars. We are made of stardust. The sun's death will seed the galaxy with new possibilities, new stars, new planets, maybe even new life. So keep looking up, keep asking questions, and marvel at the universe's wonders. Science lets us read the story of the cosmos and our place in it. Let's keep exploring together.